In this lesson, we're going to review the Pythagorean Theorem. And you may ask, when will I ever use this? It turns out the Pythagorean Theorem can be used a lot in real life, especially if you're building, measuring, or designing things. But in terms of this course, you're going to use the Pythagorean Theorem in questions that involve triangles, especially when we start to learn trigonometry. You're going to use the Pythagorean Theorem in questions that involve finding the surface area or volume of pyramids and cones. And we're going to use the Pythagorean Theorem if we're asked to find the shortest distance between 2 points. So when we start to talk about our Pythagorean Theorem, one of the most important things to keep in mind is that it only works for right triangles. That's because the Pythagorean Theorem relates to the hypotenuse, and a hypotenuse only exists in a right triangle. In a right triangle, the hypotenuse is the name that we give the longest side, and it's always across from the right angle. So if we take a look at this triangle, we can tell it's meant to be a right triangle because of this symbol, and that symbol points to where the hypotenuse is. The other 2 sides of the triangle are called its legs. One of the versions of the Pythagorean Theorem tells us that the square of the length of one leg added to the square of the length of the other leg is equal to the square of the length of the hypotenuse. Now that's a lot of words and letters, so we use some symbols to make this a little faster. The symbol for the hypotenuse is always c. So when we talk about the hypotenuse being squared, we can also write that as c squared. And the legs are called sides A and B. It really doesn't matter which side you call A or B, your Pythagorean theorem will still work for you. And this form, a squared added to b squared is equal to c squared, is the version of the Pythagorean theorem that most students are most comfortable with. It's what you've seen before. Now let's take a look at some examples. Here's a right triangle, so our Pythagorean theorem will work. It might look like we only have information about one side, but wait, those 2 little symbols on the legs tell us that those 2 legs are the same length. So we can add in the other leg also being 1 unit long. The side that we don't know is our hypotenuse, c. In previous math classes, you may have seen your teacher draw some squares. This is a geometric way to represent squaring the length of the sides. Unfortunately, this sometimes leads students to a little bit of confusion, and it doesn't support our theme of algebra in this course as much. So we're going to ask you not to draw squares on the sides of your triangles for this course. Our theme is algebra, so we're going to use algebra to represent our Pythagorean theorem. That good old a squared added to b squared is equal to c squared. In this case, a and b, the legs, are 1 and 1. So let's fill those into our formula. Now let's see, 1 squared is 1, so this can be 1 added to 1 is c squared. 2 is equal to c squared. And to finish solving, to undo the squaring, we're going to take the square root of each side. Our hypotenuse c is the square root of 2, or approximately 1.41 units. Let's take a look at another example. In this case, we've got sides of 3 and 5, and we need to find side n. A lot of students are going to dive right in, fill in their 3 and their 5 for a and b, and they solve to find out that this missing side n is about 5.83 units long. Wait a minute, that's longer than the side of 5 that we had. Is n supposed to be the longest side? No, the right angle is pointing at 5. It's our hypotenuse. It's the longest side, c. What went wrong here? We filled the 5 into the wrong part of our Pythagorean theorem. So when we look at our a squared added to b squared is equal to c squared, we're going to make sure that the 5 squared is on the side of the equal symbol all by itself. So now we can figure out that 3 squared is equal to 9 and 5 squared is equal to 25. In order to solve this equation, we'll subtract 9 from each side. We find out that n squared is equal to 16. To undo squaring, we take the square root of each side, and n must be equal to 4. This triangle gave us sides that were 3, 4, and 5 units long. This is an example of a Pythagorean triple. A trio of numbers which are true in the Pythagorean theorem is called a Pythagorean triple. The other triangle we saw in this lesson is not a Pythagorean triple because 1.41 is not a whole number. Our Pythagorean triples can also give us larger groups. 3, 4, 5, multiplying by 2 will give us 6, 8, 10, or multiplying by 3, 9, 12, 15. It's also helpful for students to recognize some of our other common Pythagorean triples because it may save you a little bit of work down the road. So there's our quick review of the Pythagorean theorem. You may remember it is a squared added to b squared is equal to c squared, but we also encourage students to think about the length of a leg squared added to the length of the other leg squared being equal to the length of the hypotenuse squared to help avoid filling numbers into the wrong place. Keep in mind that this only works for right-angled triangles, that we expect students to show their thinking as solving equations, and most especially that C represents the hypotenuse. Our goal with this topic is to be able to use the Pythagorean theorem to find missing sides of right-angled triangles, and that's going to help us down the road to use those side lengths to help answer larger problems.